Hello, this is the Physics 2211 Lab 2 submission for the lab of motion of the falling object. So the main goal of this laboratory is to understand the motion of a falling object and the forces acting on this object in motion. For this lab, we will discuss the effects of drag and the effects of the force of gravity. Essentially, the experiment consisted of comparing and contrasting two computational models for falling objects, one with the force of drag acting on it and one without. For this lab, we will also conduct calculations to find the terminal velocity of the object, and overall, the results indicated that the computational model with the drag force was a much better representation of the motion in the model in the observation without the force. So some concepts to know for understanding this lab a little bit better is Newton's second law. So the idea that acceleration of an object in motion is equal to the net force of the object divided by its mass. The force of gravity, which is that the acceleration due to gravity on the Earth's surface is approximately 9.8 meters per second squared, and the force of drag, which is that drag acts in the opposite direction of a moving object, and it is found using the formula below, where F of D is the drag force, CD is the drag coefficient, A is the reference area, P is the density of the fluid, and for this laboratory, we use the density of air, and V is the flow velocity relative to the object. So for this experiment, an object was dropped from the top of a meter stick, which was used to measure the distance, and it was recorded to measure the time. Here, the system is the box, and the surrounding areas are everything else. So in this case, the system would be the item that was dropped. It was a small plush animal for this experiment, and the surroundings are everything else. And in order to construct the position versus the time tables, a tracker was used. As you can see, the tracker is observed at the beginning of the experiment, so before the drop, and at the end of the experiment, so after the drop, and the tables are included to the right. From the tables, we can see that as the object falls from the top of the meter stick, the velocity increases. So for the experiment where we used the computational method only using gravity, the time steps were slightly adjusted to include the mass of the object, which is referred to as the ball for facility, and that is to the bottom left corner. And then to the right, we can see that the while loop accounts just for gravity. Now, if we look at the computational model code for gravity and drag combined, the code is essentially the same as prior, but there are adjustments made to account for the force of drag, with the line of B equaling to 0 changing to B equaling to 1.72. To find this value, I used the formula that I mentioned in the second slide. And to the right, we can also see that the while loop also contains an equation to account for the drag force, and it is not just that force of gravity as previously shown. So for our discussion, we can say that the model accounting for gravity and the force of drag was a much more accurate depiction of the observed motion of the falling object. And we can talk about the what ifs questions mentioned for the assignment. So the model is most likely to reach terminal velocity. The model most likely to reach terminal velocity is a model accounting for the force of drag as well. And towards the end, the magnitudes of gravity and drag will become equal to one another. And the second question answer is that if the object was thrown downwards initially instead of just being dropped, this would actually not affect the terminal velocity, since it relies solely on the magnitude of the force of gravity and the force of drag. In other words, the initial velocity would not change or affect the terminal velocity in any way. Some possible errors that could have been made to affect the calculations and the results of this lab are that the height of the experiment was taken through mobile software, and it may not be the most accurate measurement and could affect calculations. I did not have access to a meter stick, which could impact some of our results and some of our values. The second possible error for this lab scenario is that the angle of the camera recording could have affected the tracker software used as well. But nevertheless, here are the results presented, and thank you for your time.